everyone, and welcome to our first lecture of the semester. So one thing I forgot to mention is the textbook we're using. And we are using the OpenStax Chemistry 2nd edition textbook. Not the Adams First one, we're doing just the regular chemistry textbook. It's completely free for you to read online. It's a great textbook, a lot of schools use it. You can buy a hard copy of it if you want it. You do not have to. I think it's like $56 on Amazon. So if you want to be able to have a physical copy, you can. It's pretty cheap. But again, you do not have to. In fact, OpenStax even has an application that you can have to save things like highlights and notes that you make digitally. All right, let's get started. So we are beginning with Chapter 1, Essential Ideas. So there are 6 sections to this chapter. We have chemistry in context, phases and classification of matter, physical and chemical properties, measurements, measurement uncertainty, accuracy and precision, and mathematical treatment of measurement results. So chemicals are all around us. These different substances, we have different processes that make them, or chemicals that also are used in different processes that keep us clean, they keep us healthy. They make up everything. So that's what we're going to start by talking about. So in section 1.1, we're going to outline the historical development of chemistry, provide examples of the importance of chemistry in everyday life, describe the scientific method, differentiate among hypotheses, theories, and laws, and provide examples illustrating macroscopic, microscopic, and symbolic domains. So let's first start by defining chemistry. Chemistry is the study of composition, properties, and interactions of matter. And we'll talk about what matter is. It's stuff. Okay? There's been attempts to figure out what matter is and its behavior way more than 2,500 years. The Greeks, for instance, proposed that matter consisted of 4 elements: earth, air, fire, and water. There was the practice of alchemy, which was where alchemists tried to transform base metals into noble metals. There were times where some chemicals were used for dyes or perfumes, for pottery, all over the place, all in history. So here's a picture or a drawing of an alchemist workshop in about the year 1580. So alchemy is not chemistry, though there were some discoveries made in the practice of alchemy, but it was not scientific at all. Most of it, any discoveries, were pretty much accidental. But nonetheless, this is what helped us get to modern chemistry. So isolating drugs from natural sources, metallurgy, the dye industry, these all especially came from alchemy. So chemistry is often called the central science. In fact, when I took general chemistry, that's what my textbook was called, the central science. And that's because it's interconnected to all these different STEM disciplines. For those of you that aren't familiar with the term STEM, that stands for science, technology, engineering, and mathematics. So here's just a little example for you. Chemistry right there at the center, and all these different fields somehow are connected to chemistry. Some of them directly, something like environmental science and nuclear chemistry. Other ones maybe need a couple steps, something like geology goes to geochemistry, and then we can connect back to chemistry. But nonetheless, this is why chemistry is the central science. You can generally learn chemistry and be able to use that and translate it to all these different types of disciplines. Some places where you might see chemistry in everyday life: digesting food, making polymers for clothing, polyester, that means it's a polymer, or cookware, things like Teflon, even credit cards, making crude oil into gasoline. My cat just jumped on me, I'm sorry. And so we're going to be talking about different ways that we can change matter, and how we can classify matter and the energy changes that are going to occur. But what I want to stress is that matter is anything that takes up space and has mass. Oops. Which we'll talk more about that as we go. Keep that in the back of your head. So now let's talk a little bit, though, about the science of chemistry. It's based on observation and experimentation. So the first thing that happens is we make an observation. Okay, and then we make a hypothesis. And a hypothesis is how we explain that observation. Okay? We have laws in science, and what these laws do is they describe or predict something that always happens. Okay? And then a theory is basically a hypothesis, a very strong hypothesis that explains something that happens in nature. So we have these different areas that we study. And we have these different domains that we study that what we're talking about, the scientific method, can be applied to no matter the type of domain. Starting with the macroscopic domain. Macro meaning large. Okay, so this is everyday life, the realm of everything around us, something that is large enough for us to see or touch. Okay. Then we have the microscopic domain, micro meaning small. And this is the imagination. Okay, so maybe there's some parts of the microscopic domain that are visible through a microscope, okay, but you can't really see it with just your bare eye. You may not even really be able to touch it. And then we have the symbolic domain. So symbolic meaning symbols. So this is using language or letters, variables, symbols to represent the microscopic and macroscopic domains. So chemical symbols, elements on the periodic table, they're elemental symbols. This is part of the symbolic domain. So let's talk a little bit more about the scientific method. And I'm willing to bet that every single one of you, without even knowing it, has actually done the scientific method. And my favorite way to compare this is everyone's favorite topic of changing a dirty diaper. So I have two nieces. They're almost 10 now. But when they were babies, they're twins, I got to babysit them a bit. And being that there were two of them, sometimes you would smell poop, but I didn't know who it was. So the first step of the scientific method is observation and curiosity. This is really the very first thing. So I'm babysitting the girls and I smell poop. I have made the observation that there is poop somewhere. Someone's got poop in their diaper. So the next step is to make a hypothesis. The hypothesis is an attempt to explain our observations. It needs to be able to be tested as well. So to test my hypothesis, so I think that Mackenzie pooped. I don't think Cheyenne pooped. I'm guessing it's Mackenzie. So that's my hypothesis, is that Mackenzie pooped and needs her diaper changed. So now I need to test my hypothesis. That's our next step. So this is to perform an experiment, make more observations, see if the experiment supports your hypothesis. So I go, and how do we test the hypothesis that she pooped? We check the diaper. I've seen all kinds of different diaper testing. I've seen moms who just put it straight up to their nose and sniff. I've seen the like kind of 2 fingers in the bottom of the diaper. Ugh, it all terrifies me. Nonetheless, we check. And I look and oh no, she's dry. Okay, so it's not consistent with my prediction. So I need to make another hypothesis. So since I can conclude that Mackenzie didn't poop, then it must have been Cheyenne. So now I think Cheyenne pooped. This is my new hypothesis. So now I'm going to check her diaper, and I look and I notice, hey, there's poop there. So this now gives me a conclusion. Okay, that Cheyenne pooped and she needs her diaper changed. Now, there are ways to have stronger hypotheses that basically always happen, or observations that it's tested over and over, and you have these constant observations for everything. Instance, everything falls down. Okay, gravity pulls everything down. It's a law. Okay, observation becomes a law when it's seen to constantly happen. Okay, so laws don't explain why or how something's happening, but they tell us what will happen. Now, if there's a bunch of testing on a hypothesis and the testing constantly supports it, that hypothesis becomes a theory. So theories are very strong ways of describing why something happens, maybe even how they happen. Okay, so hypotheses and theories describe. Observations and laws, you're just looking at it on the surface. And now here's some examples of the macroscopic, microscopic, and symbolic domains. So if we're looking at this picture of this iceberg, looking at the air, the iceberg, the ocean, this is all the macroscopic domain. Okay, this is all stuff we can see and touch. But if we were to zoom in at the molecular level, okay, we can't see it, but what's actually happening, we can see molecules of water that are solid, gaseous, and liquid. Okay, so these guys over here on the side, or the drawings themselves, not the formulas, represent the microscopic domain. And the symbolic domain is represented by these chemical formulas here, and then also telling us the state of matter. G for gas, S for solid, L for liquid. So macroscopic, microscopic, and symbolic.